Hello and good day. I, Asha Subramaniam, and my groupmate name is Anik Muizuddin, and we are from Group 2. So now I'm going to present the multisim simulation for part 1. There are altogether 3 parts, which are part 1, part 2, and part 3. So in part 1, it is required to build the first order low pass filter. So we already built it in this multisim software with the VRMS 1 and frequency of 1 kilohertz. Actually, the frequency it is required to vary from 1 kilohertz to 1 megahertz. So first of all, uh, input we enter 1 kilohertz first and simulate it. Oh, sorry. Let's see the interactive first. Okay, as you can see here, for the low pass first order low pass filter, the output of the op-amp we get 1.5 volt where when the frequency is 1 kilohertz. Before that, I forgot to mention it. We uses op-amp LM741CN and it requires 12 volt with R2 1.5 kHz and R1 as 1 kHz, and there is a capacitor with 1 nanofarad. So just now this is the voltage of the output op-amp 1.5 when that is frequency of 1 kHz. So when we varied it, we have done it varied it until 1 megahertz. So when it is 1 kilohertz, we get 1.5 volt. When 500 kilohertz, we get 0.16 volt. And lastly, when we vary it until 1 megahertz, we get 0.12 volts. So as for the theoretical calculation, for the frequency cutoff, we obtain 159.15 kilohertz. So now let's see the simulation frequency response. So let's AC sweep. So we set this start from 1 kilohertz and we vary it until 1 megahertz and then we save it. Okay, we run it. So this is the AC sweep frequency response for this circuit for first order low pass filter. As you can see here, the intersection between these two is the cutoff frequency. So I have already recorded here in my report. So this is the result. As you can see here, the simulation cutoff frequency we get 102.1498 kilohertz. So as you can see here, we already calculated the percentage of error that compared the theoretical calculation and simulation calculation. So we obtained 35.57% of error. Part 2, the first order high pass filter. So as for this part 2, we have to simulate the first order high pass filter circuit and then with input of 1 VRMS and vary the signal frequency from 1 kHz to 10 Hz, and then we have to plot the gain frequency. Now let's see the circuit that we have done. So this is the circuit for part 2, which is first order high pass filter. So we set it as 1 VRMS as required, and then 1 kilohertz for the frequency. Here is the C1 as 100 nano, R1 1 kilo ohm, and R2 1.5 ohm kilo ohm, and we uses the LM741CN with 12 volt, and then we connected with the multi-sim and a board plot. So now first we see the voltage output voltage for the op-amp. When it is 1 kilohertz, the output voltage that we obtain is 0.8 volt. So we have to vary it until 10 hertz. So I have already done it. Yeah. So this is the, when it is 1 kilohertz, we get 0.8 volt. When it is 200 hertz, we get 0.19 volt. And lastly, when it is 10 hertz, we get 0.01 volt. Next, let's see the graph, the frequency response for this. So we varied it from 10 hertz to 1 megahertz. So we see the graph. So this is the graph that we obtained. As you can see here, the cutoff frequency. So I already mentioned it over here. So this is the output gain frequency response for part 2. The error of the error is 47.25 because the simulation result is 839.77 Hz, and the theoretical calculation that we calculated, we get 1.592 kilohertz. So when we calculate the error percentage, we get 47.25%. Next, for part 3, which is the second order low pass filter, we are required to build a circuit in part 1 and part 2 to design a second order of low pass filter. So let's see the circuit. So this is the circuit. This is our group circuit that we built. The input voltage, we set it as 1 VRMS with frequency of 1 kilohertz. The resistor R1 and R2, we set as 3 kilo ohm for both, and then the capacitor C1 we set as C1 and C2 we set as 0.01 microfarad, and we uses LM741CN with 12 VCC and VEE of negative 12 volt. There is two additional resistor, which is RF1, which is we use as 10 kilo ohm, and RS as 15 kilo ohm. Okay. We also had connected the multimeter at the output of the op-amp. So now let's see the output voltage that we obtained. So let me run it. Okay, So you can see here, this is the output voltage, which is 1.673 volt. Next, we are going to see the frequency response of this filter. So we set it. So first we set it as AC sweep mode, and then save it and click run. So as you can see here, this is the frequency response of this second order filter. The intersection point is called as critical frequency. So the theoretical calculation that we obtain on this calculation is 1.1 gigahertz.